So if we have a look at an actual sort of example of a box and whisker plot, you can see that we could kind of label each of these values so that we can see what the least value is, what the lower quartile and so on. The lower quartile are. The other thing that this maybe helps to show is the way of identifying an outlier by using the interquartile range. So the idea behind finding an outlier is anything that is, if you take the interquartile range, so in this case the interquartile range is going to be 16 minus 7, so it's equal to 9, and you multiply that by 1.5. So if I multiply it by 1.5, I get 13.5. So I add 13.5 onto the upper quartile, and anything that is above that number would be deemed an outlier. And if I also then take that 13.5 and subtract it from the 7, anything below that value will be deemed an outlier. Now, that will obviously on this side take me into the negative, so it's probably unlikely that I'll find an outlier over on this side. But if we have a look at this one here, 16 add 13.5, so 16 add 1.5 times the interquartile range gives me 29.5, so therefore 31 is above that value and would be considered to be an outlier. Just to see a representation of that, if I take this is obviously the width of this is my interquartile range, I'll multiply it by 1.5, so that will make the length of it approximately like that. And so if I stick that on top of the upper quartile, anything beyond that value will be deemed to be an outlier.